Hi guys, myself and in this video shall see another problem on LeetCode. Binary tree pre-order traversal. So what do you mean by a binary tree? Binary tree is a tree which can contain at most each node will contain at most of two children. So here if you see first node contains two children, fine. Two contains two children, three contains one children, okay. Then 4, 5 doesn't contain any children. 6 contains one child and 7 doesn't contain any children. So it contains at most lesser than or equal to 2 children each node. And we have to do the pre-order traversal of that. So how do we perform the pre-order traversal? As we know in binary trees we have two types of traversals. BFS and EFS, breadth first search and depth first search. In depth first search, it comes pre-order, in order, and post-order. So in pre-order, it will be root, left, right, but in order, left, root, right, and post-order, left, right, root. So how do we get to know this root, right, left? What's the order of the traversal? So we have left and right. Have it. This is right and left we have. So first comes left and right. So pre means pre. So root will be pre at the beginning of beginning. That's root, left, right. In means inside. So between left and right, root comes. Post means at the end. So at last root comes. So this is how we can remember it. So how do you perform the pre-order traversal? So in this question they have asked for the pre-order traversal. So how do you perform that? So as you know in pre-order traversal, it's root, left and right. So I'll erase this. Okay, I have written root, left and right. So we should start with the root. So entire tree, if we consider, this is the root, right? So one will be the root. So at first we start from the root node, and that is one. So first root should be printed. So one will be printed. Next comes to the left. So left means this is a subtree which you have. So in this subtree, if you see which is the root, again 2 is the root. So print 2. Let's check whether it has left. Yes, it has left. That is 4. So when it comes to 4, again check. 4 is the root, so print that. Then check whether it has left children or right children. Does it have? No. So go back. Next, after 2 here, it has right children as well. So print 5. So this subtree is done. Root is done. Root left. Now right part is left. So that is this right subtree. So when it comes to here, this is the root, right? So first root has to be printed. 3 will be printed. Next left. Is there any left node? No. Then go to right node. So this is the right here. So when it comes to right node, you have to check. Again, this is the root. So print that. Does it have left node? Yes, 7. So again for 7, you have to check left and right is not present. And 7 will be printed. So this is the pre-order traversal of the given binary tree. So in code, how do we do? So what we'll do first root, then go to left subtree, right subtree. Inside that subtree, you have to go and write the answer. But without this root left right also you can find a pre-order traversal. So how do we do that? For that there is one other trick you can use, short trick. In if there is any emergency you can use that. So I'll mark, since it is pre, I'll mark it everything. See pre in post. So pre means left, in means inside, post means right. So pre, every node mark like this. Okay. So once you mark every node, just traverse it from the beginning. So it moves like this, like this. Then inside, inside, outside, it comes here, 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 then here, here, then back to the root. This is one circle. So if you observe, start from here. The arrow mark which is pointing to the line, write all those things. So one is pointed to arrow mark, so one. Next two also. Four also pointing to the line. Then come here, here. Okay, five also pointing. Then move here, up, up, up. Is one is pointing down? No, it is pointing to the left, which is already written. Next comes to 3. So after 3, it is 6, then 7. So after that, here no one is pointing, no arrow mark is pointing. Yeah, you can check here, these two are same. 1, 2, 4, 5, 3, 6, 7. That means your pre-order traversal is correct. So this is one other small trick which you can use in any emergency condition. So now we will see how we code this. So in the given question, they have told you have to return the traversal in a list. So first we'll create a list. Okay, let's name it as a result equal to new array list. And for traversing, I'll write a function. So traverse of. So what we need to traverse? One is the starting with the root node, comma the list. Because while we're traversing, we have to keep on adding to the list. So we'll use a method of recursion here. What we'll do is, so you have a function to traverse into the list, right? So if inside the function, this is a function, okay? If node is equal to null, what we need to do? Here it is node equal to null. Just need to return. So here first is a root. Root means that particular value. So you have to print that data, right? Here you have to add that to the result. Dot add or push back in C++. You have to add the element at the root to the list. So that will be node dot value because it's given as value, then left and right pointers. So next we have to traverse to the left. So if it is traverse is a function, so traverse of node dot left, comma this list, then traverse of node dot right, comma this list. So how does it works? See, we start from the root node. While calling the function, we have to give root comma result. So it will start traversing from the root node because string node equal to root they have given. Next, we check whether if node is equal to null, no, it is not equal to null. So we have to add result dot add of node dot null. So one will be added to the list. Next, traverse of node dot left. So this will be called. So again check if node is equal to null. No. Again result dot add of node dot val. So two also will be added to the list. After this, again traverse of node dot left, comma result. So this here comes here. So 4 is it equal to null? No. This dot add of node dot val. 4 we also added to the list. So after adding 4, traverse of node dot left. Is it present? Left? No, it is not present. So it will since the node will become null, it will return. So next you have to traverse of node dot right. So check here as well. Here node also equal to null, so it will also return anything. So this will be return. You go back, then comes to here 2. So for 2 left is done. Then check for right. So 5 is there. So for 5 again node is not equal to null, so we will add 5 to the list. So after adding 5 to the list, then you have to traverse left. So it is null, right also null. So both are done. Perfect. So to traverse back, it will go here. Okay, it will go back again here. So here, adding value is done, left is done, but right subtree is still remaining. So this C. So right will be called, 3 will be called. So once your 3 is called, it is not equal to null, it will be added to the list. So then left will be called. Is left present? No. Then call the right. So is right present? Yes. So once you come here, again check if node is equal to null. No. Then result dot add of node dot val 6 will be added to the list. So after adding to the list, check left. Yeah, 7 is present. It's not equal to null. So add 7 also to the list. So after that, what happens? 7, is it does it have a left node? No. Does it have a right node? No. Then try trace back. Then again for the 6. This left is done. So check for the red, no, not present, then trace back. Then again for the 3, left is done, right left is done, go again trace back. For this also trace back and it will get a null. So this is how you solve a question. So now we have a traverse and it will at last you have to return the result only. We will write the function private return void traverse of what? One is the tree node, comma, the other will be the list. Result. So next what happens? If node equal to, now you have to check. If so, then just return. Otherwise, we have to add result dot add of what? We have to add the node value, node dot value. Next, call the left. So traverse of node dot left, comma result. Similarly, traverse of node dot right, comma result. So this is for Java. So here we just have directly using the pass by value. But in C++, we have to do pass by reference. So that's why we are using pointers and reference here. So why are we using the reference in the C++ and not in Java? Because in Java we use the objects, so that we take a reference of that object and pass it to the function. And when it comes to outside the function, it will get reflected in the original structure itself. But in C++, we are not using the object, so that's why you have to take the reference. If you do not take the reference, it will take a copy of this list and it will perform the operation. But or whatever you do the copy, it will be an overhead to the program, right? So that's why we use the pointers as a reference. And here vector int result. So if node equal null pointer, then push back we use here node dot left, node dot right. So we submit this. Yeah. Okay, successfully submitted. If you understood the concept, please to like the video and subscribe to the channel. We'll come up with other video next session. Until then, keep learning. Thank you.